Assalamu alaikum. Welcome student to the course of Electric Machine 1, lecture number 13. Uh, Today we are going to study the Y connection and some example, and then delta connection. In our last lecture we compare the Y and delta connection. So today we are going to study in more detail. So what is Y connection? You people heard that mostly we transmit in delta and distribute in Y connection. So the three single phase circuit of the figure, that is the figure. We studied this in our last lecture too, that we have a three phase system having an individual resistor connected with phase 1, phase 2 and phase 3. We studied this in our three phase generator and its output. So the three single phase circuit of figure are electrically independent. Consequently, we can connect the three return conductor together to form a single return conductor, is shown in our figure. This one, see the difference. We have a return path, each have their own return path, and here we have the one return path in which IA, IB and IC return, which we call the neutral's conductor. This reduced the number of transmission line conductor from 6 to 4. The return conductor, called the neutral conductor or simply a neutral, carries the sum of the three current as shown in figure, that is IA plus IB and IC. You people will think that the cross section of this conductor, the neutral conductor, should be 3 times that of the lines A, B and C, or phase A, phase B and phase C. However, the diagram clearly shows that the sum of the three return current is 0 at every instant. For example, at instance corresponding to 240 degree, IC is equal to I maximum and IB is equal to IA is equal to minus 0.5 I max, making sum of these current equal to 0. That is, when we draw a three-phase current together, and we consider an instant, any instant, we will get IA plus IB plus IB is equal to 0. This is the diagram in which having an individual return path, and here we have one neutral path for all the three phases. This is the system without the neutral. So we can therefore remove the neutral wire altogether without any way affecting the voltage or current in the circuit. The circuit of figure, composed of the generator, transmission line and load, is called a three-phase 3-wire system. The generator as well as the load are said to be connected in Y because the three branches resemble the letter Y. So this is the system in which we don't have neutrals, and this is the generating part, and this is the load, and this is the transmission line. So we don't have any neutrals, so we call this system a three-phase 3-wire system, and this is a three-phase 4-wire system, 4-wire in terms of neutral conductor. So the circuit of figure is shown is called a three-phase 4-wire system. The neutral conductor in such a system is usually the same size or slightly smaller than the line conductor. Three-phase 4-wire systems are widely used to supply electric power to commercial and industrial users. In our homes or shops or industries or restaurant, mostly we use a single phase. From this we take a tape from this three-phase system. So there is also a neutral, so mostly distribution is done to three-phase 4-wire system. A line conductor are often called phases, which is the same terms applied to the generator winding, meaning the phase 1, phase 2, phase 3, or phase R, phase Y, or phase B. So here is an example for you people to solve it in home. We have a generator which generate a line voltage of 865 volt, and each load resistor has an impedance of 50 ohm. We need to calculate the voltage across each resistor and the current in each resistor, and then the total power output of the generator. You people can go through the three-phase system, the formula of star and delta connection we studied in our last lecture, and this is sort of homework for you people to refresh your mind about a three-phase system. Here is another example. We have three identical impedance are connected in delta across a three-phase 550 volt line. If the line current is 10 amp, we need to calculate the current in each impedance and the value of each impedance. So this is the problem related to delta connection. The first one is related to Y connection. So go through it and solve it. It is an assignment and homework. Now, what is delta connection? A three-phase load is said to be balanced when the line voltage are equal and the line current are equal. This corresponds to three identical impedance connected across the three-phase line, a condition that is usually encountered in three-phase circuit. The three-phase impedance may be connected in Y, that is star, or in delta. So this is the diagram of the delta connection. We have a three impedance, a balanced load, and here is its correspondence current. We also studied that the phase in line current relation and the phase in line voltage relation in delta and star in our last lecture. So go through it and remind it. Thank you for today's lecture.